Hey y'all, Miss Mayhew here, and I'm going to walk you through some of the examples on the activity for how shape affects efficiency. So they already give you the formulas that you will have on your formula sheet on the AP exam, and that is that the surface area equals the length times the height times the number of sides on a cube. And then the volume equals the length times the height times the width. So then, once you know your surface area and your volume, then you can divide the surface area by the volume to get your surface area to volume ratio. So let's do the first one together. Okay, cube A is 1 by 1 by 1. So to find the surface area, I'm going to multiply the length of 1 times the height of 1 times the number of sides on a cube, which is 6. So that's going to be 1 times 6 equals 6. Now to calculate the volume, I multiply the length times the width times the height, which is 1 times 1 times 1, which is 1. Then my surface area to volume ratio will be my surface area, which was 6, divided by my volume, which was 1. So my surface area to volume ratio would be 6. Now you're going to go ahead and try for the other ones. So pause here and try cube B. This is what you should have gotten. Now pause and try cube C. This is what you should have gotten. Now pause and try for cube D. This is what you should have gotten. Now what happens to the surface area to volume ratio as a cube gets larger? Okay, as the cube gets larger, my surface area to volume ratio gets smaller. And remember, the surface area to volume ratio for cells is important because that shows the efficiency of the cell to be able to interact with its environment and diffuse things across the cell. So what this means for cube-shaped cells is the smaller the cell is, the more efficient it is. Now we're going to do the same calculations as above, but we're going to be looking at columns now, where instead of increasing all 3 sides, we are going to increase just the height by 1 centimeter each time. Starting with the surface area of column A. Okay, this one we are looking at 1 by 1 by 1. We've already calculated the surface area and volume ratios, so I'm just going to copy those from above. For column B, we're looking at a 1 by 1 by 2 column. So let's calculate that surface area. To do that, I'm going to start by doing the surface areas of the top and the bottom squares. There's 2 of them, and they are both 1 by 1. So the surface area of this top part and the corresponding bottom part are both 1. So I'm going to start with 1 plus 1. Then I'm going to add the surface areas of all 4 rectangles that make up this middle portion. These are each 1 by 2. So 1 times 2 is 2, but there's 4 sides. So I'm going to add 2 plus 2 plus 2 plus 2. That gives me a surface area for column B of 10. My volume I'm going to calculate just by multiplying my length times width times height, which is 1 times 1 times 2, which gives me 2. My surface area to volume ratio is my surface area of 10 divided by my volume of 2, which gives me 5. Now go ahead and try the other 2 on your own. Start with volume C and pause here. This is what you should have gotten. Now on column D, pause here. This is what you should have gotten. Now you'll graph this on the next video.